Welcome to EDU World Space.
Chapter 14, Question 74. You have studied the gas phase oxidation of HBr by O2, so there's a reaction over here, and this is said to be the overall reaction. So the proposed mechanisms are 1, 2, and 3 are these 3 steps. So confirm that the elementary reactions add to give the overall reaction. How we do that is, what I add all the left-hand sides to the right-hand sides, and then check if everything goes smooth or not. So HBr plus O2 plus HOOBr plus HBr plus HOBr plus HBr is going to be our left-hand side, and our right-hand side is going to be HOOBr plus 2HOBr plus H2O plus Br2, and this is going to be the right-hand side. Now, if I add all these and rearrange them, what we're going to get is HBr, HBr, and this is HBr. So we have 3 HBr, and we have 1 O2, and we have HOOBr, which is going to cancel with this guy, and we have an HOBr, well, this HOBr, let's erase that because we have that HOBr on the right-hand side too, but there are 2 of them, so one of them are going to cancel. So we're only going to end up with 3 HBr plus O2. And on the right-hand side, what we're going to have is HOBr plus H2O plus Br. Now this doesn't look like the same as what we have over here. So how can we get to that step? As you can see, there are 2 H2Os, and the only H2O producing step is this step. So if I multiply this entire step by 2, then let's see what we're going to get. We're adding 1 more HOBr, on the left-hand side, and 1 more Br, and that is going to add 1 more H2O and 1 more Br. So if you do this and rearrange, HOBRs are going to cancel. This, I'm sorry, this is going to be HBr, not Br, so let's write HBr. So 3 HBr, 1 more HBr, so we're going to get 4 HBRs plus O2, and on the right-hand side, we're going to have 2 H2Os and two Br2s. These are going to be Br2. So now this guy very much looks like this guy. So we can confirm that the elementary reactions add to give this overall reaction. In part B, they're asking, based on this experimentally determined rate law, which step is the rate determining step? So this is a first order with respect to HBr and first order with respect to O2. So we need to determine the slow step because slow step is always the rate determining step. Over here, we have, let's write this as a rate law, K HBr and O2. So this is going to be the slow step, which is the rate determining step. In part C, what are the intermediates in this reaction mechanism? So the intermediates are, we get intermediates at the end of a reaction, and we consume those intermediates at the starting of the next reaction. So HOOBr over here is consumed. So we can say HOOBr is an intermediate. Let's see if we have more. 2HOBr over here is consumed by 2HOBr here. So HOBr is also our intermediate. If you are unable to detect HOBr or HOOBr among the products, does this disprove your mechanism? Not really. We're not going to be able to detect these HOBr and HOOBrs among the products simply because they're intermediates, because they get consumed within the overall reaction. That's why we won't be able to see that among the products, but we still had them in the intermediates, so it does not disprove our mechanism.